Hello my dear students, welcome to IMS GATE Academy. I hope all of you are fine. Very good evening to one and all. All of you please mention your branch. I am welcoming all of you regarding GATE Foundation course regarding digital circuit subject. This subject is common for 4 branches: EC, Electrical, Instrumentation and Computer Science. This is one of the most important and scoring subject as per GATE exam point of view for all these 4 branches. Yeah, so today is the first session regarding digital circuit subject. So in this particular session, we will just discuss the introduction about the subject digital circuits. Okay, so first of all, let us see the basic signals. Okay, so all of you put the heading types of signals. I will draw 2 signals on the board, so try to identify these 2 signals. Say for example, here I have drawn one signal like this with respect to time axis. Horizontal axis or x-axis is nothing but time, whereas y-axis is nothing but voltage or amplitude. This is one signal. Now I will draw one more signal. Now, in this signal, here x-axis is nothing but time, just like the previous one, and y-axis is nothing but voltage, similar to the previous one. Now, can you identify what is the first signal and what is the second signal? Yes, all of you can guess that the first signal is analog signal, whereas the second signal is digital signal, right? So the first one is analog signal, whereas the second signal is digital signal. So here if you observe regarding the first signal, say for example, here voltage axis I am considering, the minimum value I am considering say 0 volt, and the maximum value, say for example I am considering it as Vmax. So here the signal value, amplitude value, now tell me within this range 0 to Vmax, how many possible values you are having? For this particular signal, within this range 0 to Vmax, how many possible values this particular signal can have? Obviously infinite, right? Infinite possible values are there. So that means whenever you are having any signal, if that amplitude value can be anywhere within that range, that means infinite possible values are there. So then we will call that particular signal as analog signal. Whereas here if you observe this particular signal, here this particular signal we are operating only at 2 levels. Okay, if you carefully observe, here the signal value stays at 0 volt, or another one we are considering it as 5 volt. this signal stays at 0 volt or 5 volt, 0 volt, 5 volt, like that. Okay. So whenever the signal value or amplitude value stays only at two finite values, here in this case we are considering 0 volt, 5 volt, or if you want you can consider minus 5 volt, 0 volt, like that. Okay, whenever any electrical signal, if you can operate only at two voltage levels, then we will call that particular signal as digital signal. That means in the real world, whatever the physical quantities we are having, like temperature, pressure, etc., from morning to evening, say for example, from morning 8 a.m. to night 8 a.m. Okay, so from morning to night, the temperature will vary with respect to time continuously, right? So if you want to transmit this particular information to the other user, so the temperature is a physical quantity. If you want to convey this particular information, you have to use or you have to represent in terms of the electrical signal like voltage or current. Okay, so when you represent the physical quantity in terms of the electrical signal, originally you will get analog form like this. Okay, now in general, instead of directly sending the analog signal from the transmitter, analog signal we will convert into digital, and then we will transmit this digital signal from the transmitter. At the receiver, you will receive the digital signal first, and then you can convert this digital signal back into analog, and from the analog signal you can extract the information, that is a physical quantity. Now if you observe in this particular entire process, at the transmitter, instead of directly sending the analog signal directly, you are converting analog into digital, and at the receiver you are receiving digital signal, you are converting that digital signal back into analog, right? So why we need to convert analog into digital and digital back into analog? Any guess? Why we are doing two types of conversion? One is analog to digital at the transmitter section, and at the receiver we are converting digital back into analog. See, obviously there are some drawbacks or disadvantages will be there in the analog, right? So to overcome those drawbacks, we are converting into digital. Hi Atul, good evening. So now let us see the advantage of digital over analog, right? So all of you put the heading, advantage of digital over analog. So the first advantage, say for example, first let us see here, when you are transmitting this analog signal, suppose if you are transmitting this signal directly, then what will happen? Whenever you are transmitting any signal, yeah, good afternoon Amit, yeah, good evening everyone. Yeah, so whenever you are transmitting any signal, any electrical signal, what will happen in the course of time? In the course of time, some electrical signal like this, will be superimposed. Okay, so this is your original information, but in the course of time, this particular electrical signal was superimposed to your original signal. This is not your desired signal. Your desired signal is this one, but this is not your desired signal. So that means this particular signal we will call it as what? Noise. That means undesired electrical signal we will call it as noise. Okay, so what will happen? At the receiver, you will receive this signal. This is your original signal. Along with that, whatever the superimposed signal is there, so along with that you will receive at the receiver. Now if you want to remove the noise part, what you have to do? Say for example, if you are considering at this particular instant of time, here at this instant of time, your actual information is here, but because of the noise, you are getting more than actual. That means if you want to remove this part, you have to subtract with something. Similarly, if you observe at this instant of time, your actual information is here, but because of the noise, you are getting less than actual. That means you have to add with something, right? So at one point of time, you have to subtract with something. At some other point of time, you have to add with something, right? In order to get the actual signal, right? So for each and every iteration, if you have to do, it will take more time. That means the complexity is increasing. Okay. So that is a drawback in the analog signal in order to remove the noise spot. Now, how easily we can remove the noise spot when we are transmitting the digital signal? So the first advantage of digital over analog is effect of noise is less in digital. Effect of noise is less in digital. How it is, let us see. So for simple understanding, for easy understanding, I am considering simple signal, digital signal like this. Okay. So this is the digital signal I have considered. Now this is the digital signal we are transmitting from the transmitter, but in the course of time, the noise has been added. Noise has been added to this particular digital signal. Now, whatever the digital signal along with the noise, this particular signal I will give as one of the input. I will give as one of the input for comparator. Comparator, as the name implies, it will compare two inputs or two signals. Here for the time being, whatever the digital signal along with the noise we are having, that one I am considering as V suffix D. That one I am giving as one of the input. Now I will consider one more input. So now if you observe previous this digital signal, here digital signal we are operating only at two levels, only at 0 volt and 5 volt. Only at these two possible values. Yes or no? Now, so that means now I am considering one threshold value, that is nothing but average of those two values. Here this is 0 volt, this is 5 volt. Average of these two, how much? It is very simple calculation. What is the average of 0 and 5? All of you please respond. What is the average of 0 and 5? Very simple question, right? It is 2.5. Yes or no? So I am considering the threshold value as 2.5. Since we are operating digital signal only at two levels, either at 0 volt or 5 volt, if you are taking average of those two, that is nothing but threshold value. So I am considering that as 2.5 volt. Just for the time being, I have considered average of these two. Okay. Based upon your requirement, you can consider any particular threshold. Okay. Based on the requirement, based on the operation, based on the application, etc. Right. Now, this comparator will compare these two signals and it will produce a particular output. Now, let us see the functionality of this particular comparator. If VD, that means the digital signal along with the noise, if that value is greater than this threshold value, then the output will be 5 volt. Otherwise, output will be 0 volt. Okay. Now, if you carefully observe, during this part, the digital signal along with the noise, that value is lower or smaller when compared to the threshold level, right? So that means here output is what? 0 volt. Output is 0 volt. Now, during this part, the digital signal along with the noise, that level is greater than threshold value, right? So that means this condition is satisfying. So output you will get 5 volt. 5 volt. Okay. Now once again, if you observe during this part, now tell me, during this part, what is the output you are going to get? during this part, what is the output you are going to get? See, we already completed similar part here. Yes or no? Initially, during this part, you got output as 0. Similarly, once again, the same part of the circuit or part of the signal you are getting, right? So you'll get 0. Yes. Now if you observe what we have done, see, whenever you are transmitting digital signal, that time also noise will be added. Okay. But since we are using comparator, by the help of comparator, even though noise has been added, we are able to remove the noise part. Now you can observe whatever the signal we are getting at the output of comparator, now at the input side, just remove the noise part, whatever yellow color line was there. So that yellow color part, if you remove, this signal and this signal, whether both are same or different? Both are same, right? So that means even though noise has been added, with the help of comparator, we are able to remove the noise part, right? So that is the reason, that is the main reason why we are going for digital. Why we are going for digital. Effect of noise is less. This is the one of the most advantage and one of the important advantage why we are converting analog signal into digital. Okay, I already discussed earlier, in the analog, if you want to remove the noise part, there is a difficulty, but how easily we are able to remove the noise part with the help of digital signal and by using comparator. I hope it is clear for everyone regarding the first advantage of digital, why we are converting, or what is the advantage of digital over analog, why we are converting analog into digital, or why we are using digital when compared to analog. Okay, I hope it is clear for everyone. This is the first reason and the most important reason or most important advantage of digital over analog. That is, effect of noise is less. Effect of noise is less. Okay. Now, whatever the case I have considered, I will consider the same case and I will give one more advantage of digital over analog. Now, if you observe, say for example, at the receiver, you are receiving this analog signal along with the noise part. Now, at the receiver, can you say that whatever the signal you have received at the receiver, can you say that the sender or transmitter has sent the same signal? Is it possible? Is it possible? No, it's not possible, because you are having analog signal like this, but because of the noise, whatever the signal you are receiving, that signal is nothing but the original signal, and which is superimposed with the noise also. You cannot say that the sender has transmitted the same signal. But now in the digital signal, now if you observe this particular signal, now whatever the signal here you got, and in this particular digital signal, you are having the digital signal is there and superimposed noise also is there. Okay, but with the help of comparator, since you are able to remove the noise part, you are getting noise free digital signal, right? Now tell me, just by looking at this particular signal, because this is a signal you are receiving at the receiver, right? Since you are receiving this particular signal at the receiver, now can you say that the sender has transmitted the same signal? Yes or no? Just by looking at this particular signal, can you say that the sender has transmitted the same signal or not? Yes, obviously, because see, originally you are having the same digital signal. If you remove the yellow color part, this signal, both are same only. That means whatever the information you are receiving at the receiver, you can trust on that particular signal or you can trust on that particular information, right? So that is the advantage of digital. Whereas in analog, whatever the information you are receiving at the receiver, you cannot trust. Whatever the information you are receiving, you cannot say that the sender has transmitted the same information. But whereas for digital, whatever the information you are receiving at the receiver, you can assume or you can confidently say that the sender has transmitted the same information, right? So the second advantage is reliability is more. Reliability means we can trust whatever the information we are receiving, we can trust that particular information. Okay. So these are the two advantages of digital over analog. I have considered the same case. I have given two advantages. First advantage is effect of noise is less. The second advantage is reliability is more. Okay. I hope it is clear for everyone up to this point. Now let us see the some more advantages of digital over analog. Say for example, whenever I hope the students from EC, electrical instrumentation, and in fact computer science students also might have in your BTech college laboratories, whenever you are doing the experiment, okay, whenever you want to find the voltage or whenever you want to find the current, you might have used some sort of meter like this. Can you identify what is this meter? Say for example, I am considering, for the timing I am giving the reading as in terms of volts. 0, 1, 2, 3, 4, 5. Suppose for the time being I have represented in terms of volts. What is this meter? And you might be having the divisions, small divisions will be there like this. Within 0 to 1 you will be having 10 small divisions. Hi Nikhil, good evening. I hope you can guess. When you are doing the experiment, if you want to find the voltage, okay, you will use voltmeter, right? Yeah, thank you Nikhil, thank you. You will use voltmeter, okay. You might have having the meter reading like this, right? You will be having 0 to 5 volt, and here scaling will be like this, 0, 1, 2, 3, 4, 5, and between 0 to 1, 10 small divisions. Similarly, 1 to 2, 10 divisions, 2 to 3, 3 to 4, 4 to 5 like this, right? Now, what is this particular meter? It is analog meter, right? Analog meter. It is a voltmeter. So, in terms of generalized, I am calling voltmeter or current ammeter. Together, if you are considering as a measuring meter, so it is an analog meter, right? So here if you observe, say for example, if the pointer exactly showing to the 1, then you can note it as 1 volt. Similarly, if the pointer, if it is showing somewhere exactly middle of, that means this yellow color part, then you can note it as 0.5 volt. Like that, if the pointer is showing to this first small division, then the first small division value is how much? Between 0 to 1, I have considered 10 small divisions. So that means the first small division value will be 0.1 volt. Because here range is 1 volt, and within that one, I have made into 10 intervals. So that means the first small interval is nothing but 0.1. Okay. So if the meter exactly pointing to the first small division, you can note the value as 0.1 volt. Okay. Right. Now, so what will happen? Say for example, if you want to, suppose if the pointer is showing somewhere in between 0 and first small division, if you want to note the exact value, is it possible? Between 0 to 0.1, if the pointer is showing, okay, if it is not showing exactly in between 0 and 0.1, maybe somewhere towards 0 side or towards first small division side, okay, it's not possible to note the exact value. Yes, correct Nikhil, correct. But if you want to note down the exact value, what you can do, just like here what we have done, between 0 to 1 we have made into 10 small intervals. In the similar way, if you want to note down the accurate value between 0 to 0.1, if you want to note the accurate value, what you can do, once again you can make the another scale on the same meter. You can make one more scale. Okay, say for example, between 0 to 0.1. Just like between 0 to 1, I have considered 10 small divisions. In a similar way, between 0 to 0.1, if you consider 10 small divisions. Okay. Now, in this case, the first small division value will be 0.1 divided by 10. That is nothing but 0.01. This is called recalibration of the scale. Okay. Based on your requirement, based on according to which range you want the accurate value, accordingly you can change the scale, so that here when you're having the scale like this, it is difficult to note down the accurate value if the point is showing somewhere between 0 and 0.1. But if you want to note down in between 0 and 0.1 accurate value, when compared to this one, here you can get more accurate, because we have changed, we are using one more scale. This is called recalibration of the scale. Okay, earlier you're having the scale 0, 1, 2, 3 like that, in between 0.1, 0.2, 0.3 like that. And now between 0 to 0.1, we have made into 10 small intervals like that. Okay, this is called recalibration of the scale. That is practically possible. But here in all the meters, either ammeters or voltmeters, here you will be having what? Needle or pointer. That is what? Mechanical element. That is a mechanical element. Here, in order to make the deflection, here the first small division value is nothing but 0.1. Okay. Now, within this range, 0 to 0.1, here the first small division value is 0.01 volt, right? Now, the pointer, in order to make the deflection for such a small change, since the pointer is a mechanical element, there will be some practical limitation just to make the deflection for such a small change. Okay, see, I am saying that the meter can measure the value, but because ultimately whatever the measured value is there, you have to note down based on the meter reading position, right? The pointer position. But in order to make the deflection for such a small change, there may be the limitation. Right? So that's why if you want to note down the more and more accurate values, okay, so this is one of the drawback is there in analog meter. See, practically the possibility is if you want to get more and more accurate values, you can change the scale, but practically since the pointer has to make the deflection for such a small change, if the pointer is not making the deflection, then you will face the difficulty in order to note down the accurate value, right? And one more drawback is there in analog meter. I hope all of you can guess. In general, whenever you are doing the experiments in your BTech laboratories, okay, BTech college laboratories, generally you used to do as a batch of 3 students or 4 students. Okay, so say for example you are measuring voltage. Okay, you are measuring voltage by using voltmeter. Whether all the 3 students, whoever in that particular batch, whether all the 3 students reading will be same when you are doing the experiment in your college laboratory. All of you please respond. What I mean to say is, so one person is exactly parallel to the meter, and okay, and one person is left to him and one person is right to him. Whether all these 3 students reading is same or different. If you are using voltmeter or ammeter, obviously no, right? So that time you will get one kind of error. What is that? Yes, that is called parallax error, right? Parallax error. Yes, the student who is exactly in parallel to the meter, his reading or her reading is correct. The other 2 students' readings are wrong. Okay, because those are not in exactly parallel to the meter, right? Okay, but whatever the drawbacks, 2 drawbacks that we have discussed with the help of analog meters, these 2 drawbacks you can easily overcome with the help of digital meter. Yes or no? So can you give the example of digital meter? I already mentioned regarding voltmeter or ammeter. Here, if you are having the reading like this kind of meter is nothing but analog meter. I hope all of you while you are doing the experiments in the laboratories, you might have used one type of 1 meter. So what is that meter? That belongs to digital. Yes, you might have used multimeter, right? Here you will be having the values will be displayed in the 7-segment LED form. So for the timing, I'm just considering 4 values. Based on the requirement, you will be having accordingly. Okay, right. So for example, this is integer part, this is fractional part. Okay, so here what will happen? The meter will measure the value and it will display on this 7-segment LED display. 7-segment LED display. Similarly, if you want, you can use LCD display also whenever you want to display the values. So whenever you are doing the mini projects or major projects, that time if you want to show any values, okay, you can use 2-line LCD display or 4-line, etc. based on the requirement according to the project, etc. Okay, so here whatever the measured value is there, that is directly displaying here. Okay, by using 7-segment. Here you are having 7 LEDs, so that's why we are calling it as 7-segment. Okay, right. So now, so based upon, if you want more and more accurate value, accordingly you can consider based upon your application or requirement. Accordingly, you can consider after the radix point that many digits. Okay, so suppose if 2 decimal place accuracy is sufficient, then accordingly, or 3 decimal places. Accordingly, what will happen? There you can just turn the knob based upon your requirement. Accordingly, the value will be automatically adjusted. Okay, if you want after 1 decimal place, or after 2 decimal places, or after 3 decimal places, etc. Okay, so that much easy is there. With the help of digital meter, you will get accurate values. You will get accurate values. Okay, and here just you are reading the value, that's all. You are just reading the value. But here you have to be very careful whether the pointer is showing to which point exactly like that. But here, whether you are seeing from this side, or whether you are seeing exactly in parallel, or whether you are seeing from towards that side, from any direction, if you are seeing the same value, that means there is no parallax error. There is no parallax error in the digital meter, because just simply already the value is displaying in the digit form, in the decimal form. Directly you have to simply note down, right? So whatever the drawbacks are there in analog meters, all those drawbacks you can easily overcome with the help of digital meters. In this way, nowadays for displaying purpose, we are using whatever the measured values are there, if for just showing, whether we are using based on the requirement either LED or LCD display. I hope it is clear for everyone. So with respect to meters, in terms of analog and digital, these are the, whatever the 2 drawbacks I have discussed here, how easily we can overcome with the help of digital meters. I hope it is clear for everyone. You will more study regarding analog meters, digital meters, etc. in the measurement subject. So regarding that, Nikhil sir will cover. Okay, right. So just to get some feel or idea, I have given here also in terms of regarding the advantage of digital over analog, right? Okay. Now let us see some more advantage of digital over analog. So whenever you want to store any information, so earlier days, whenever you are in childhood time, okay, if you want to see the movie in the theater, okay, so in your childhood days, you might have observed that, say for example, in your city, there are 2 theaters nearby, okay. So from one theater to another theater, okay, earlier days, the movie, entire information is stored in the form of reel, right, magnetic tape, okay. So from that theater to this theater, they have to, pass few reels like that, okay. But nowadays, we are storing the entire information with the help of digital, right. So in the form of CD, DVD, pen drive, hard disk, etc., right. So wherever, so in the analog form, for storing the information, there is a lot of processing or complexity will increase or size will increase. But with the help of digital, you can store more and more information in the, without any errors, and it is easy to carry or easy to store, etc. So for storing transmission and processing, in all these applications, okay, wherever, because of analog, if there is any ambiguity or if there is any errors, okay, in all such cases you can convert analog into digital, okay, so that there won't be any ambiguities. You can easily store the information, you can easily transmit the information, you can easily process the information. That's why earlier days you might have heard the subject title as like analog signal processing, but nowadays digital signal processing, right? So everything you are studying, everything whatever related to ECE, electronics, okay, or electrical, whatever the processing applications, okay, whatever the operations you are doing with respect to the electrical signals. But nowadays, earlier days it was there in analog, but so many advantages are there in digital. That's why nowadays it is converting everything into digital for storing, transmission and processing. Here processing, just for simple understanding or easy understanding, you can say that just to store a particular bit or information and then you can transmit. That itself also you can say it is a processing, or you can say any mathematical operation also. Okay. And one more advantage of digital over analog, digital circuits and systems can be programmed. Digital circuits and systems can be programmed. Say for example, in this particular subject you will learn, okay, say for example adder will be there, one of the topic. So basically you will give two inputs, okay, and it will perform addition output. The same adder will be there inside microprocessor also, just with the help of one simple command, like say for example add B. For the timing I am considering 8085 microprocessor. You are having one 8-bit information in accumulator and another 8-bit information B register. If you are using add B, then what will happen? Accumulator content will be added with B register content and the result will be stored back into accumulator. So physically you are having one arithmetic circuit that is called adder, okay. So that particular circuit the microprocessor is utilizing, but you are giving simply one command. With the help of this one command, the microprocessor internally using that particular physical hardware circuit, and it will produce the operation. After that you are getting the result. That is the beauty of the digital circuits and systems. That means whatever the hardware circuit you have designed, the same hardware circuit based on the requirement you can use n number of times just with the help of simple commanding or instructions. That is called programming. Okay. So in this way you will be having number of advantages in digital. That's why we are converting analog into digital. I hope it is clear for everyone regarding advantages of digital over analog. All of you please respond. Up to here whatever we have discussed, is it clear or not? So it is very, very important. That's why in this beginning, in the first session, introduction to digital, I have given, first I started with the types of signals and then I have discussed the advantages of digital over analog case by case. With respect to signals we have seen, with respect to meters we have seen, that means measuring meters, and then with respect to various other operations also we have seen, right? Now I will show one simple question. So all of you please answer this one. Since we have number of advantages in digital, can we ignore analog completely? All of you just think about it and respond. Yeah, up to now we have discussed advantages of digital. Yes. Okay. So since we have number of advantages in digital, can we ignore analog completely? No. Because see, if you recall beginning of this particular topic regarding types of signals, okay, if you recall, in this real world, in this physical world, whatever the quantities we are having, like pressure, temperature, or if you observe whatever I am talking now, okay, that particular voice, physical form, all these are all the physical quantities in this practical world or real world are by nature all are in analog only. That means, say for example, whatever I am speaking now, okay, if whatever I am speaking, that particular voice, if you are having in digital form, if you are just using the, if you are just keeping the earphone and if you are listening my digital signal, whatever I am speaking, can you hear anything? Can you understand anything from that? You can hear, but can you understand anything from digital signal? No, because ultimately you require analog signal only. Okay, if you are having analog signal, from that you can convert back into the physical form. So after that you can easily understand, because in this real world all the quantities by default are in analog form. So ultimately analog only required. That's why if you recall whatever the at the transmitter section, if you observe, beginning we are having analog signal only, and the receiver we require analog signal only. But in the process, in the course of time, because there are so many drawbacks or difficulties or complexities are there in analog signal, so to overcome all those things with the help of digital, since we can do easily and there are many advantages in digital, that's why we are converting analog into digital, and then only we are transmitting, and the receiver you are receiving digital signal, and that digital signal you are converting into analog, and from that analog you can extract physical information based on the requirement, right? So that means we cannot ignore analog, right? Yes. Okay, so since we have discussed two types of signals, based on that now let us classify the electronic circuits. So all of you can guess, it is a very simple question. We can classify the circuits into two types. One is analog electronic circuits. Analog electronic circuits, or in short you can call it as analog circuits. The other one is, you can call it as digital electronic circuits, or in short you can call it as digital circuits. See here, for the time being I have broadly classified the signals into two types only. One is analog, another one is digital. But in order to convert analog into digital, you will perform various other operations also, like sampling, quantizing, etc. Okay, so the four types of signals you will learn in the signals and system subject, but here in this particular subject, just for understanding purpose, I have considered broadly, I have classified the signals into two types. Okay, right. So analog electronic circuit or analog circuit. So as the name implies, it is very simple. Whatever the electronic circuit you are having, if you can operate that particular circuit with the help of analog signals. Analog signals means that particular signal amplitude could be of one of the infinite possible values, whatever the range you are considering. Say for example 0 to 5 volt or 0 to 12 volt. Within that range, if the signal value could be of any value, and whatever the output you are getting, that particular output also, it could be of one of the infinite possible values. Okay, so then we will call that particular electronic circuit as analog electronic circuit, or otherwise in simple words you can call, or in short words you can call it as analog circuit. Okay, so basically in this particular subject, when you are studying analog circuits, okay, you will come across the diodes, the circuits. In the electronic circuits, you will use the diode as one of the main components. So with the help of diodes configuration, you will get various applications like clippers, clampers, etc. And similarly with the help of transistors. So regarding transistors, you will be having BJT, MOSFET, JFET, etc. Okay. So with the help of transistors, you will learn regarding amplifiers and oscillators. Okay. So in this way, if you observe any of these electronic circuits, in these circuits, if you observe at the input side or output side regarding signals, those signals will be in the analog form. That's why we are calling that particular circuit as analog circuit. Okay. So various electronic circuits which you are operating with the help of analog signals, you can learn or you can study in this particular subject, analog circuits. Okay. So regarding all those concepts you will learn in the analog circuit subject. So regarding that, Gopal sir will discuss. Now in our course, okay, in our subject we'll focus on digital circuits. That means here you are having electronic circuit, but this circuit you can operate with the help of only digital signals. Only digital signals. That means you are operating only at two levels, either 0 volt or 5 volt, right? So since you are operating only at two levels, then that particular signal we are calling it as digital signal. And if that particular electronic circuit, if you are operating only with the help of digital, okay, then we will call it as digital circuit. Okay. Our main focus is only at those two levels. Okay, right. So here we will study various digital circuits, okay, which we can operate only at two levels, 0 or 5, like that. That's all. See, when you're calling 0 volt and another one is 5 volt. Okay. So in general, we will represent the 0 volt, we will consider as in terms of logic. Okay. When you observe these two, 0 volt and 5 volt, okay. So this is lower, this is higher. So accordingly, you can say this is logic low, and this one is logic high. Or in terms of values, we will represent this one as bit 0 and this one as bit 1. So whenever you are representing in terms of values 0 and 1, we will call it as it is binary, because we are using only two possible values. Okay. But if you are representing that particular information in terms of the electrical signal, then we will use voltages 0 volt or 5 volt, right? So then we will call that particular signal as digital signal. So broadly speaking, there is a difference, slight difference between the term digital and binary. But as for this particular course concerned, you can use these two words as synonymous. Okay. See, it is very simple. The word digital we will use or refer for the signal. Okay. Whenever you are having the number, that time we will, instead of digital, we will use the term binary. Okay. These two you can as synonymous, but in terms of real meaning, there is a slight difference between digital and binary. I hope it is clear for everyone. Okay, right. So now let us see the syllabus of digital circuits. So here we are having total 7 chapters are there. Okay. So as I mentioned earlier, in the digital circuits or digital computers, okay. So we are dealing about only two values, 0 volt and 5 volt, or zeros and ones. That's all, right? So that particular number system is nothing but binary number system. And in our day-to-day life, also we are using one number system. What is that? In our daily life, we are using one number system, right? From morning to night, okay. Whether we can pass any day without using number, is it possible? Right from the beginning, after wake up until the point before you go to the bed, without using number, is it possible to pass the day? Not possible, right? Yes. In our day-to-day life, we are using decimal number system, right? So in the first chapter, we will discuss what are the various number systems are there and how to do those conversions. That means from one number system to the other number, how to do the number system conversions, and then we'll discuss various binary codes. Okay. And in the second chapter, we'll discuss Boolean algebra and K-maps. See, for this entire subject, okay, if you want to understand this the first chapter is the basic. After that, the second chapter is also the basic, because just like whenever you want to learn any language, say for example English language or any language, okay, if you want to learn, okay, if what is the first step? Suppose if you consider English language, first you will learn the alphabets, and then you will learn the words, and then you will learn the, with the help of grammar, you will make the sentences, okay, and once if you are good at making the sentences, you can make the paras, okay, and in that way you can make number of pages or stories, etc., right? So this is the way of learning any language. In a similar way, regarding digital also, okay, the first and foremost thing is regarding zeros and ones, okay, that is the first thing. And all these circuits, since we are operating only at two levels, what kind of operations we can perform here, what kind of logical operations we can perform here, etc., okay. So here also we require some set of rules and regulations, right? Just like in your whenever you are studying maths, okay, engineering maths, okay, you might be having the first chapter as matrix algebra or linear algebra. There also the title algebra is there. So that means you are performing some sort of operations. There, linear algebra or matrix algebra, that means you are performing various operations on the matrices, right? Similarly here, in this entire digital circuits, it is based upon one particular algebra that is based on two values, 0 and 1, right? And this particular algebra has introduced by a mathematician named George Boole. So accordingly, the word Boolean algebra has come, okay. Here we will discuss various rules, and with the help of laws, how to do the simplification, okay, set of rules and laws will be there, how to do the simplification of the Boolean function, okay, and then we'll discuss the min terms, max terms, etc., okay, and then there will be one more approach in order to do the simplification, that is called K-maps, okay. Once if you are good at first chapter and second chapter, then it is easy to understand the third chapter. So here in the third chapter, you will be having various logic gates, okay, and what are the specialty of each and every gate, etc., and how to implement various other logic gates, okay. And then if you want to classify the entire digital circuits, if you want to classify, you can classify broadly into two cases. One is combinational and other one is sequential. Digital circuits we can classify broadly into two types, combinational and sequential. Now I hope most of you know the difference between combinational and sequential. What is the basic difference between these two? What is the basic difference? The students who are from EC electrical instrumentation, with respect to your control system also, just for analogy point of view, can you correlate the combination circuit belongs to which, and similarly sequence circuit belongs to which one? Just for analogy point of view. Yes. See, this combination circuit is nothing but, just for analogy point of view, combination circuit is nothing but open loop control system, and sequence circuit is nothing but closed loop control system. Because what is the difference between open loop and closed loop? In the open loop, there is no feedback path, right? Whereas in closed loop control system, there is the feedback path, right? Similarly, in the combination circuit, you don't have any feedback path, okay? But in the sequence circuit, you are giving the previous value as one of the operand for my next operation, right? So that's why you are storing the previous value somewhere, that is called memory. So that means combination circuit along with memory is nothing but sequence circuit, okay, right? So here we'll see various combination circuits, here we'll see various sequence circuits. So these two are the major chapters, okay? Among all the chapters regarding digital circuits, if you want to classify broadly into two parts, combinational and sequential, right? So for understanding these two chapters, the first three chapters are very, very important. Say for example, whenever you want to construct any building, Okay, suppose if you want to construct a building of 10 floors, okay, what is the first step? What should be the strong? What is the first one that should be strong? If you want to construct a 10-floor building in order to be strong, yes, obviously foundation, right? Once the foundation is strong, no matter, okay, based on the, that particular land capacity, accordingly you can construct the number of floors, right? So in a similar way, if you want to understand thoroughly each and every circuit related to the digital, okay, if you want to understand these two chapters crystal clear, okay, then the first three chapters are very, very important, okay, right? And then here sixth chapter will be there, data converters. So if you observe in the beginning of this particular class, okay, I showed with analog, digital, etc. So based on that, here you will be having like analog to digital converters, digital to analog converters, and then whatever the third chapter, logic gates will be there. So all these logic gates you can implement with the help of set of electronic components. So those set of electronic components we will call it as logic family. So here basically we will implement with the help of CMOS logic, right? So with respect to the gate exam point of view, so the first 5 chapters for CS branch, the syllabus is up to 5th chapter. Weightage is 4 to 5 marks. For electrical, up to 6th chapter. For electrical branch, the syllabus is up to 6th chapter. Weightage is similar, 4 to 5 marks. Whereas for EC and IN, all the chapters. EC and IN, all the chapters. For EC, it is around 8 marks. For instrumentation, 8 to 10 marks. So just by looking at this particular syllabus and weightage, you can guess that how much this particular subject is scoring subject for all the 4 branches. Okay. So here, this is one of the most important and scoring subject. See, as I mentioned earlier, if you are able to understand each and every basic concept of first 3 chapters, then you can easily understand and you can attempt these questions. Sorry for the interruption. So here, once if you are strong on the first 3 chapter basic concepts, then it is easy to attempt any question regarding 4th chapter, 5th chapter. Okay, so that's why it is very, very important to be strong on the basic concepts of first 3 chapters, right? Yes. Now, so this is about regarding the syllabus of digital circuit subject, okay, with respect to the 4 branches and weightage. Okay, now let us see the importance of this particular subject. Once if you understand each and every concept of digital circuits, okay, say for example, if you want to do the masters, even in your BTech also, okay, in 3rd year or 4th year, okay, so you will be having, just like CS branch students will be having programming languages like C language or Java language, etc. Right? In the similar way, EC branch students, okay, if you want to be, okay, if you want to write some, programming, etc., okay, regarding in terms of hardware, right, whatever the concepts you have studied in the digital, just like adders, subtractors, okay, or logic gates, etc., okay, if you want to implement those physical components, okay, with the help of languages, okay, those languages are called VHDL or Verilog. You'll be having, these are the hardware description languages. Here you can design the physical components, whatever you have studied in the digital circuit subject, okay, and you can interconnect those components, and you can design the projects also, like J-links or will be there, that is the physical FPGA board will be there. Okay, you can interface the components physically. Okay, whatever the external components you want to interface, you can interface, etc. You can do the experiments or projects you can do. And similarly, say for example, whatever the 7 chapters we have mentioned regarding digital circuit subject, if you understand all these concepts, okay, as I mentioned earlier, okay, in the microprocessor also you will be having adder circuit, right? Similarly, you will be having logic circuit. Okay, so in order to understand the concepts of microprocessor, it will be very much easy. And here the most interesting thing is, whatever you have studied in the digital circuits, all those physical components will be there in a IC or chip form, only with the help of instructions or commands, or with the help of, so here we will use one language that is called assembly language. With the help of that language, you can use the physical hardware circuit just with the help of one command or set of instructions. With the help of program, you can do the various projects. Okay, you can use the physically present hardware. Okay, that particular hardware circuit will be used, will be called or will be utilized by the processor, but from your side you are just giving a command, that's all. That is the beauty of microprocessor. And once if you are good at microprocessor, then you can easily understand microcontroller. Similarly, so this microcontroller we will call in short as system on chip, because here in the microprocessor you are having what? ALU, that is arithmetic and logic unit, register array will be there, right? So, and control unit will be there. Here in the microcontroller, you will be having microprocessor also. Along with that, some IO ports will be there. IO related devices will be there. So that's why in general you will call the processor and IO devices together we will call it a system, right? That's why in general computer we will call it a system. In a similar way, here in short, the microcontroller you can consider as the simple system on chip, or in short you can call it as SOC, system on chip. And if that system on chip, if you are having the programmable feature, then we will call it as programmable system on chip. Okay, so when you go for MTech specialization in the embedded systems, there you will study regarding programmable system on chip. Here you will be having both whatever the analog related circuits or components, similarly digital circuits or components you will be having. Okay, you can interface based on the requirement according to your project, and here you can write the program with the help of assembly language or C language based on the requirement. Okay, so in this way, in order to understand microprocessor, microcontroller or programmable system on chip or embedded systems. So for understanding any of these subjects or these subjects, okay, so the digital circuits is the one of the basic subject we can say. Okay, so all these subjects are, okay, all these subjects are based on digital circuit subject. So digital circuit subject is one of the most basic and foundation subject. Okay, right, and it is the most interesting subject and scoring subject with respect to GATE exam point of view. Even after GATE, what you will do, either you will join based upon your, if you are able to get very good rank, you may apply for the PSU job, okay, or you may go for masters, right, MTech specialization. So when you are choosing, if you are from EC or electrical, if you are choosing embedded systems or VLSI, okay, there mostly you will be having internal hardware circuits will be there, digital only, right? So that's why this is the one of the most basic subject. If you are able to understand this subject, you can easily understand all these subjects. Okay, as I mentioned earlier, when you are constructing a building of 10 floors, okay, the foundation is the very important. Suppose if you not made the foundation very well, okay, no matter at any point of time the 10-floor building may collapse, right? So but if foundation is very strong, okay, then no matter based on the, you know, based on the requirement, whether you are constructing 10 floor or 20 floor, whatever it may be, the building will sustain for longer, right, if the foundation is strong, right? In a similar way, if you want to become whatever the specialization you are going to do in the MTech, okay, related to, even some of these subjects will be there in your BTech also. The more detail you will study about these subjects in your masters. Okay, so for understanding all these subjects, the digital circuit subject is the basis or foundation, you can say, right? Okay, so I hope all of you got the overview regarding why we are going for digital when compared to analog. Okay, what are the advantages are there, and in this particular subject with respect to GATE exam point of view, syllabus and weightage we have discussed. Okay, now in this foundation course in our IMS GATE Academy YouTube channel, okay, regarding this foundation course for GATE 24 and 25, so upcoming GATE aspirants, okay, for all the aspirants of GATE 24 and 25, students who are from EC, electrical, instrumentation and computer science, for all the 4 branches, this digital circuit subject is common. Okay, most of the chapters are same, most of the chapters are part of the syllabus, only 1 or 2 chapters are not there for few branches, right? That we already covered. So regarding digital circuit subject foundation course, okay, in our IMS GATE Academy YouTube channel, okay, here we will cover, okay, what are the topics I am going to cover regarding this subject, I will discuss now. The timings will be 4 p.m. to 5:30 p.m., 1.5 hour time. So regarding first chapter, number systems and codes, so tomorrow we are having, that is 7th April. So here these are the topics that I will discuss, okay, regarding first chapter. Okay, so in the first chapter, whatever the topics are, the basics are very important, okay, in order to understand the upcoming chapter topics. Okay, those topics I have placed here in a sequence. Here in the number system conversions, first we will see decimal number, we will consider the decimal number, and we will convert into other number systems. We will convert into other number systems. Other number systems. And similarly, the other number systems we will convert into decimal. Okay. On 13th April, we will discuss the other conversions, like suppose if you are having a number which belongs to R, radix R, if you want to convert into radix power n, or similarly vice versa, R power n to R. Okay, all those conversions we will discuss here. And then on 14th April, we will discuss basic arithmetic operations like addition, subtraction, and then how to find the base or radix. This is a very, very important topic. Okay, generally it is very important for all the branches and exclusively, and it is even more important for CS branch. You will get variety of GATE questions from this particular topic, base or radix. And then data representation is one of the most important topic that I will discuss on 20th April. And then in this particular chapter, the last topic is binary codes that I will cover on 21st April. So these are the topics I will cover regarding first chapter. Okay, so this is the timetable. So similarly, the second chapter is Boolean algebra and K-maps. So these are the topics in a flow I will discuss on these particular days. Okay, so on 3 dates, 27th April, 28th April and 4th May, I will discuss the topics related to Boolean algebra, and then 5th May and 11th May, I will discuss the topics related to K-maps. After that, regarding third chapter logic gates, on these 3 days, 12th May, 18th May and 19th May, I will discuss regarding the logic gates. Okay, regarding logic gates, the basic points we will discuss, and we'll consider basic circuit diagrams, and we'll discuss variety of gate questions also. Okay, and variety of gate questions and interesting questions we will discuss. Okay, right. Now, if you observe here, up to here I have mentioned third chapter. After that 4 and 5 I have not mentioned, because 4 and 5 are the heart, right? So that is a major topics. Okay, so in this foundation course we won't discuss regarding 4th and 5th chapters, but if you are interested regarding 4th and 5th chapters, we will cover in another YouTube sessions. Okay, so in the foundation course, our main agenda is we want to discuss the basic concepts which are required. Okay, right. So after that we'll discuss regarding data converters. So regarding data converters, on 25th May, we will discuss the basics only related to the op-amps regarding voltage division rule or current division rule, etc. And then regarding logic families, so on 26th May, here also we will discuss the basics only. Okay, so here in CMOS, we will be using two types of transistors. One is NMOS transistor and another one is PMOS transistor. When NMOS transistor will be on or off, similarly PMOS transistor when it will be on or off, and similarly what is the CMOS structure, what is the advantage of CMOS, etc. we'll discuss here, and even some of the logic gates we will implement in this particular session with the help of CMOS logic. So this is the plan regarding digital circuit subject regarding foundation course in our YouTube channel. So all of you kindly share this particular information with all of your friends, okay, those who are preparing for GATE 24 or 25, okay. So because this subject is one of the most important and scoring subject, okay, so please share this particular information so that all of your friends also can benefit, okay, by attending these sessions, right? Yes. I hope all of you will share this useful information regarding the timetable of digital circuits with all of your friends. Yeah. So now I would like to show this particular slide. Here, all these are our GATE 2023 toppers of our IMS GATE Academy. Okay. So how many of you want to have your photo in the next year? Okay. So if any of you are want to have, right? So if you are aspiring to get the top rank in the next year GATE 2024 exam, right? So you can start your preparation with our IMS GATE Academy. Okay. So all of you, what you can do, you can just come to our website imsindia.com. After that, here you can click on GATE Mechanical. Okay. Just click on this one. After that, one web page will come. So after that, you can just enroll for zero fee program so that you can start your preparation, your GATE preparation you can begin. Okay. So here you will just fill one basic form. Okay. So after filling that form, you're having the access of 100 plus hours of concept videos, 12 chapter tests, 6 subject tests, and 6 previous GATE papers. Okay, according to your branch. All right. So all these features you can access just for, you don't need to pay anything, right? Zero fee. You don't need to pay even single rupee. You can access all this. Okay, so that what will happen, you can have the basic. Okay, you can just start your GATE preparation. Okay, right. And here we are having in our IMS GATE Academy, we are having live classes and physical classes. So based on your interest, okay, so according to the nearby city, you can contact accordingly. These are our counseling numbers, okay, telecallers numbers for counseling. If you want to get the proper guidance regarding the GATE and importance, okay, regarding our classroom programs, etc., more details, okay, you can contact. If you are from Bangalore, you can contact this number. If you are at Vijayawada, you can contact this number. If you are from Nagpur, this number. From Ahmedabad, here. And if you are from any other city, you can contact this number. So here regarding live classes, here you will get 800 plus hours of live sessions with live interaction, and then 130 plus online tests, 22 to 30 theory books and exercise books for GATE plus PSU, 12 one-to-one personalized mentorship sessions. These are very much helpful for all the GATE aspirants, okay, in order to get the proper guidance. These are one-to-one sessions, and then revision sessions, etc. So the GATE live online batch is going to start on 11th April. So if you are interested to join, okay, so according to your nearby city, you can contact accordingly, right? And if you are from Vijayawada, in Vijayawada we are having physical classes and online, so you can contact to these numbers. Okay, right. So in this introduction to digital, in today's session, we just discussed the main classification of signals, that is analog and digital, and then we discussed the advantage of digital over analog. Okay, in all the dimensions possible we have discussed. I hope all of you got the clarity. And then we have discussed the syllabus, weightage, importance, and how this particular subject is going to impact the other subjects based on this particular subject. And then regarding our GATE foundation course in our IMS GATE Academy YouTube channel, so regarding that particular schedule also I have given. Okay, so according to your branch, okay, since I already mentioned that, so the first 3 chapters, the first 5 chapters are common for all the 4 branches. So in our YouTube live sessions regarding GATE foundation course, first 3 chapters we are discussing. So that plan I have given. After that I have discussed one session regarding data converters, one session regarding CMOS logic family. So according to your respective branch, okay, as per the syllabus as I mentioned, so you people can attend, right? So all of you kindly share this particular information with as many friends as possible. It is very much helpful for all the GATE 24 and 25 aspirants. Even some of the students who written the GATE exam recently but couldn't perform well or couldn't get the GATE rank according to their desired or expected or target. Okay, no issue at all. Once again, you are having one more opportunity. You can start your GATE preparation. You are having 1 year ahead, right? So you can start once again and you can continue the preparation. Definitely you can get very good rank in the coming GATE exam, right? So all of you have the clear goal in the regarding your GATE exam and why you want to achieve that particular goal. If you are having these two, then no matter, it is possible. Okay, whatever may be the time and circumstances in between, whatever may be happening, but you are having high chances in order to get or in order to reach whatever the targets you are setting. Okay, right. So we'll meet you all on tomorrow. Thank you everyone.